Hello students, Ms. Slyman here. In this video we're going to be talking about the normal distribution. So normal distributions are probably the most popular statistical distribution. We see it all the time. And there is a formula for modeling the normal distribution. We can see it here, but you don't actually need to know this formula. It's not given in your formula booklet. It's not part of the syllabus, but it does exist, and deriving it is within your grasp. So if you're curious, it's something you could look up, or if you're thinking about IA ideas, this is a good one. So what we do need to know is the shape of the normal distribution. So the normal distribution is a symmetric distribution, and it's centered around the mean value. This is generally its shape. The way that we find probabilities from a normal distribution, the probability comes from the area under the curve. So if I looked at from the mean to the left, so I could say the probability that x is less than the mean in normal distributions, because this is now looking at a continuous distribution, x could take on any of these values. Less than or equal to, same thing, doesn't matter how we refer to it. In this case, we're going to have 50%. And that's going to align with this area under the curve. So that's 50%. So again, like I said, this is now a continuous distribution, first one we're looking at. We look at a mean value of mu, variance is going to be sigma squared. But when we put things into our calculator, really what we're going to be looking at is entering mean value and standard deviation. So even though we write it using mean and variance, when we use it, we're using mean and standard deviation. So norm PDF I can use if I want to draw the normal distribution, but because it's a continuous distribution, this idea of a particular value doesn't really have any meaning. Always we're going to end up using bounded values, so we're going to end up using the cumulative distribution. So here we're using it only so that we can create the graph. So by doing norm PDF with an x value of x, we can graph the distribution. And so that's what I would like you to do. I would like you to start, see what happens as we change the mean and variance. So if I go ahead and put this into my calculator and graph it, I would like you to graph these three things actually. So graph with three different mean values, 5, 8, -2. All of them have standard deviations of 2. And look and see what happens. Here's my 5, 2. Then we're going to see what happens when we change the standard deviation. So I want you to reflect, how does the shape of the graph change when we change the mean? How does it change when we change the variance? So pause your video, go ahead and graph that, see what happens, and then unpause it so we can talk about it. All right, so hopefully you've just unpaused. So when we change the mean causes a horizontal shift. And that makes sense because we said that the normal is centered around the mean. When I change the standard deviation changes cause horizontal stretches. So the greater the standard deviation, the wider the graph. The lower the standard deviation, the narrower the graph. My y-axis values are always going to be less than 1, but again, remember, it's the area under the curve that gives me the probability.